Hello again, guys. My name is Masoud. I'm a physics teacher. We are in Fairkhou's website to explain physics curriculum for you. So far, I answered and solved some questions and problems. We finished 10 questions from the standardized test prep. And this is the last question of the chapter. Let's say of the entire chapter. Let me read the question for you, and after that we will solve it together. The last question, question number 11. Mars orbits the sun, and this is the mass of sun. This number 1.99 times 10 to the 30 kilogram, right? At a mean distance of 2.28 times 10 to the 11 meters. Actually, Mars is smaller than our planet. Approximately one year of Mars becomes, let's say, 2 years of our planet. Let me read the option. Calculate the length of the Martian year, right? We want to calculate the length of the Martian year in Earth days. Show all of your work. And G is given, actually. This is a universal constant of gravitation. If you take a look at the question, actually we don't have the mass of Mars, right? A lot of students ask me, teacher, this information is not appropriate for finding for example, length of the Martian year, because the mass of Mars is not given. I'm going to tell you this information. Keep in mind that mass of Mars does not matter, right? Because compared to the enormous object like sun, let's say mass of any planet, let's say, is nothing, right? It doesn't matter mass of any planet, because let's say sun is a very let's say huge object, right? That's why we don't need the mass of Mars. Only we need the mass of, let's say, a mass of sun. So information, I summarized it for you. This is the mass of sun, radius or distance between the center of Earth, center of Mars and center of sun. And we look for delta T. It says, calculate the length of the Martian year. It talks about the year. Calculate the year, right? Let's say year of Martian year. Calculate the length of 1 year of Mars. So it talks about the delta T. But delta T is not in second, in days. Normally, let's say we solve the problem. After that, whenever you solve the problem, you get the delta T in second, right? You get whatever number in second. After that, you have to convert it to days, right? Days of Earth. Let's do it together. So firstly, I want you to use this rule. I want you to memorize this rule. I didn't, let's say, include the proof for you because it takes time. And we don't need the proof, actually. I want you to memorize this law. Omega is equal to radical G capital M capital over R cube, right? G capital means it's constant of universal gravitation. M capital means mass of sun. Keep in mind, it's not the mass of Mars. And R means the distance, mean distance between Mars and sun. Omega is equal to radical G, write G here, put G here. M, substitute the mass of sun over there. And R, we have this number, 2.28 times 10 to the 11 cube, right? I want you to cube the radius under the square root. You find this number, and this number is the, let's say, angular speed of Mars. 1.058 times 10 to the negative 7 rad per second. Right. So delta T This is omega. According to this law, actually, omega delta t is equal to delta theta over omega, right? Delta theta, it talks about 1 year. It says calculate the length of the Martian year. 1 year means one complete circle, one full cycle, one revolution. And one revolution is equivalent to 2 pi rad. That's why instead of delta theta, you have to substitute 2 pi divided by this number that we've already found it, 1.058 times 10 to the negative 7. 2 pi divided by this number, you get this number, 5.94 times 10 to the power 7 second. Teacher, are we done? Did we finish the, let's say, calculation? No, we don't finish the calculation because it says calculate the length of Martian year in Earth days. You have to convert second into the days in our planet. Delta t is equal to this number divided by 24, right? Because it's second. Teacher, how do you convert second into the, for example, hour? Whenever you divide second by 3,600, actually, it will turn to hour. So only by dividing by this number, you can convert it to hour, but we don't need hour. We need a day, right? How many hours are there in one day? Actually, in our planet, 24 hours, right? 24. So you have to multiply this number, 3,600 by 24. After that, actually, you divide, let's say, the delta t in second by the denominator, and let's say you find this number, 687 days. So 1 year of Mars is equivalent to 687 days. Approximately 1 year of Mars is twice as much as, let's say, our year. I wish I could live over there in Mars because my age will be halved over there. Thank you very much for watching this video, and bye for now.